Hi guys! Welcome back to my channel. This is Variable PH back at it again with another vlog that will surely help you guys who wants to learn or need to learn about statistics. So if you're interested, please continue on watching. Have fun, enjoy, and learn. Since I haven't vlogged for the past few weeks because of my workload, I have finally had a chance to have a moment with you, Variables. So yesterday, I asked you guys on my Instagram story to ask me a question you want me to answer or explain for you. But since I only have a limited time, I only picked 3 lucky variable subscribers to have their statistical questions answered. Hello mga Variables! You can now send me questions that you want me to answer or explain for you by posting an IG story and of course mentioning my username at variableph and also my Instagram username at _ABRAP. And I hope you guys are safe and healthy and kita-kits when this pandemic is over. Bye! And because I received so much questions from various statistical topics, I've decided to narrow it down into 3 questions regarding the t-test. Yes, that's our chosen topic for this vlog. The first question is from @Trisha Ubusan.
Hi, Variable PH. Can you define what's dependent samples t-test? Thank you. I hope you're doing well. Keep safe and God bless.
Thank you for your question, Trisha. So what is dependent sample t-test? The paired sample t-test, sometimes called the dependent sample t-test, is a statistical procedure used to determine whether the mean difference between 2 sets of observations is 0. It determines whether there is a statistical significant difference between these means. Also, a dependent t-test is an example of a within subjects or repeated measures statistical test. This specifies that the same participants are tested more than once. Thus, in the dependent t-test, related groups, it indicates that the same participants are present in both groups. The reason that it is possible to have the same participants in each group is because each participant has been measured on 2 occasions on the same dependent variable. It has 4 assumptions. The dependent variable must be continuous, the observations are independent of one another, the dependent variable should be approximately normally distributed, and the dependent variable should not contain any outliers. For the second question, @Benjan Guades asked,
Hi Variable PH! I really like your channel and I am a huge fan of yours. My question is, how do you solve for dependent samples t-test? That's all. More power to you!
in solving the dependent sample t-test, first we need to have the raw scores. Once we have the raw scores, we then need to transform these raw scores to get the difference scores or D. We also need to get the D-bar or the mean difference, the squared scores of the difference scores or D squared, the summation of D, and the summation of D squared. Once we are done getting the data, we can then proceed to solving for the population variance of the difference scores, standard error of the mean difference, and the T obtained. Sounds complicated, right? But it's actually quite easy. Take a look at the sample problem that we have. A study was conducted to determine the effectiveness of a weight loss program. The table below shows the before and after weights of 10 basketball players. Since the raw scores are now given for the before and after weights of the basketball players, we can now proceed in getting the different scores. In getting the different scores, you just need to subtract the after scores to the before scores. So for the scores of the first sample, 185 minus 169 is equals to 16. Do this until you are done with all the samples. After getting the different scores, we can then proceed in getting the summation of the different scores. How? By simply adding all the scores that you had gathered from subtracting the before and after scores. So, the summation of the different scores is 131. Once you are done getting the summation of the D, you can now also get the mean difference or D-bar by dividing the total scores with the number of samples. So that would be 131 divided by 10, which is equals to 13.1. Now that we have our different scores, we can get our squared difference scores or D squared by simply squaring the difference scores of each sample. So for the first sample, if he has a different scores of 16, then simply square it 16 times 16. Then you will get 256. Repeat this process until you get all the square difference scores of all the samples. Once you are done, proceed in getting the summation of these squared. The answer would be 3,243. Now that our table is complete, we can finally start solving for our population variance of the different scores. The formula for the population variance is this. Summation of t squared minus the squared summation of d divided by n over n minus 1. Since we have the summation of d, which is 131, summation of d squared, which is 3,243, and n, which is the total number of samples, which is 10, we can now just substitute and it would look something like this. Take note that the 1 is constant. Now that we are done with substituting, go get your calculator and pause the video if you want to see if we have the same answer. So, for the population variance, the answer is 169.656. We are using 3 decimal places because this is the rule that was taught to us by our awesome statistics professor. Wow! Would you look at that? We now have the population variance, so we can proceed with solving the standard error of the mean difference. In solving for the standard error of the mean difference, we just need to follow this formula. Square root of population variance of the different scores over n. Since we have the answer for the population variance that we solved earlier, which is 169.656, we can now substitute and it would look something like this. If you have a calculator, you can solve this easily. But if you don't, then you can solve it manually as well by simply dividing the population variance over the n, then proceed in getting its square root. So the answer for the standard error of the mean difference is 4.119. At last, we are now at the final step in solving the dependent samples t-test. So, for solving the t obtained, we need to follow this formula. D bar minus mu difference divided by the standard error of the mean difference. Take note, if the mu difference is given, then you would need to use it. If there is none, then simply replace it with 0. So, following the formula, it would look something like this. D bar, or mean difference, is 13.1 minus 0 since we were not given any mu difference, divided by standard error that we got earlier, which is 4.119. The answer would be 3.180. And for our last chosen question from our lucky variable,
Hi! Ako nga ba si Atjabal Magpantay?
Ay, at ako naman si Atloy Drenario at kami po ang inyong number 1 Variables! Woo!
Gusto po namin sana magbasa namin sin dahil sa inyo. Nakakuha din kami sa aming statistik at tinanong kami ng Pearson or number 1 fan nyo na kami since day 1.
At nagpapasalamat nga din na po pala ang aming tropang si JND. Shoutout sa iyo, JND! Woo! Dahil nakakuha rin po siya sa aming statistics subject.
At ang katanungan ngayon ay...
How do we conduct hypothesis testing for dependent samples t-test? Naku, pag napili niyo po talaga yung question namin, naku, baka magbaba-party po talaga ako, promise.
Hindi, ako magsisib ako araw-araw, hindi lang Sunday.
Baka po kami pa magbukas ng simbahan. Anyway, maraming salamat po. God bless and stay safe. Bye-bye!
wow! Grabe yung energy ni At Jobel Magpantay and At Lloyd Renario. I appreciate you guys sobra. Maraming salamat sa suporta sa pagtanong na ito. Sobrang na-appreciate ko. And let's get it. For the hypothesis testing, we have 6 steps to follow. First is, we need to identify the problem and formulate hypothesis. Going back to the statement that we had earlier, which states that a study was conducted to determine the effectiveness of a weight loss program. The table below shows the before and after weights of 10 basketball players. We can then formulate our problem and it would be like this. Is there a significant difference on weight before and after the weight loss program among basketball players? After formulating the problem, we can now formulate our hypothesis. For the null hypothesis, it would be there is no significant difference on weight before and after the weight loss program among basketball players. And for the alternative hypothesis, it would be there is a significant difference on weight before and after the weight loss program among basketball players. Once we are done formulating the hypothesis, we can proceed to step 2, which is determining the degrees of freedom, critical value, tail, and the alpha. Since this is a dependent sample t-test, to get the degrees of freedom, we use the formula n minus 1. Since our n earlier was 10, just subtract 1, meaning our degrees of freedom would be 9. For the critical value, we need to use the t-table. In identifying the critical value, we need to know our tail and alpha. In this case, our tail is 2-tailed and alpha is 0.05. Now that we know the tail and the alpha, we can locate our critical value using the t-table. In locating it, just look for the degrees of freedom, which is 9. Then look for the exact value under the alpha 0.05 in 2-tailed. So the critical value now would be 2.262. Following step 2, we have step 3, which is identifying the statistical treatment. Simply put dependent sample t-test, since this is what we used earlier. After step 3, we now have step 4, which is computation. If you already accomplished the computation, simply put your solutions in this step. Since we computed for the t obtained earlier, we can just put our solution and answer here. Succeeding step 4, we have step 5, which is the decision. In the decision, we will now decide whether it is a significant or not significant. If it is not significant, we should accept the null hypothesis. If it is significant, then we should reject the null hypothesis and accept the alternative hypothesis. To do so, we would need the critical value or t-crit, which is 2.262, and our t obtained, which is 3.180. Take note that in step 5, regardless of the sign, we should decide by looking at the bigger value. In this case, the t obtained is bigger than the t-crit, which implies that this is significant, meaning that we should reject the null hypothesis and accept the alternative hypothesis. After the decision comes the conclusion or step 6. Here, we would conclude the result. Since we rejected the null hypothesis and accepted the alternative hypothesis, therefore, there is a significant difference on weight before and after the weight loss program among basketball players. This is what the hypothesis testing looks like once it is complete. And that's it, Variabables! I hope I am able to answer your questions precisely. If you learned a lot and have fun on this video, please don't forget to like, share, comment, subscribe, and hit the notification bell to keep you updated on my next vlog. See you again! Bye!